This is part 3 in my FreeCAD tutorial with the Geneva cam sprocket. In this tutorial we're going to animate the cam like the one that you see here in the Wikipedia page. A lot of people use Inventor and packages like that to animate CAD objects, and I think we could probably do it using a script, but I'm going to use it with Python and exporting a wavefront object file. I have another tutorial that shows you how to do this, and basically I'm just going to use the Pygame standard programs that you can download from the Pygame wiki, and my other tutorial shows you how to do this. So we'll just import this camera object, or cam object, and it imports fine. Alright, so everything's working good. Now we can just import all the other objects. There's a drive gear. I'll just copy and paste this, make it a little quicker. And the plate that it all sits on, and the shafts, the drive shaft, and the camshaft. We'll rename all these. But basically what you do is you take the FreeCAD design, and then I export an object file, wavefront object file from that, or a mesh object file, and then I bring it into Blender and add colors and textures and stuff to it. So I've already done all that, and now I'm just importing them into here. I've tried to use Open Inventor before, but I could never get it to work quite right. So there we go. We've got them all imported. But I really like working at kind of a lower level. Open Inventor, or Inventor, costs a lot of money, and everything I do is open source and free because I'm cheap. Alright, we'll move these around here a little bit. So we'll just call the plate first. We don't want to, because that won't ever move. That'll be stationary. And then we'll push the matrix and rotate this drive gear, because we want this to rotate in one spot. And what I should have done when I drew these up is put them in separate files so that I could center them right on the origin, because we're going to have a problem here with this drive gear that it's going to want to rotate around the origin. We'll see when we run it here. So yeah, that's not quite what we're looking for. So we have to translate it to the origin first, and there we go. So we'll do a translation, and let's see. And we're still not quite right. I'm not sure. That seems like it should be right there, but oh well, since it's just rotating around, we'll do a quick fix. There's probably a better way to do this, but I need the math imports for that, and we have them. So we'll just make a circle and then send it back to the center of the circle. This is just real ugly and dirty, but I could actually try and figure out why it's not going to the center right. I think I might have something else wrong, but this is a quick fix, and we'll translate it and translate it back. Actually, we don't even need to do the second translation, so we'll comment that out. and we'll run it. Got something wrong here. Oh, missed parentheses. There we go. Try that again. And I've got a lot of stuff running in the background, so it's taking a while for these to load. Well, halfway there. I must have. Yep, that's supposed to be negative. Alright. And we'll try it again. And there we go. Now we're rotating stationary. We've got one gear done. Now we have to do the other one. So for this, I use this Wikipedia for solutions of triangles like all the time. And the triangle we need to solve for is a side angle side. When we drew it up in FreeCAD, we made this as a 30, 60, 90 triangle. So we know the side A, we know side B, and we know the included angle is our angle of rotation. So we're going to just plug this in right as it is out of the Wikipedia page. C equals the square root of a squared plus b squared minus 2ab. It's like the long version of the Pythagorean theorem. And this is just going to take a while to type all this out. And as you can see, I'm just doing it straight from this Wikipedia. I'm even using the same variables and everything, because the angle that we're looking for is big A, and we're going to need that big A to find the rotation of the cam sprocket. And we knew from doing it in OpenGL the distance of little a is 2.25 and little b is 4.5. Because we put those in there. Oh, I made a mistake here. It's got to be multiplied. Alright. And yep. So we know C, that's the angle of rotation. And I'm just copying this. I'll put all of the whole program up in the comments section, or a link to the program, so if you want to just download the program, you can look at everything. I know I've got this screen, the small section. And subtract the a squared. Oop. And divide 2 times b times c. Alright, that's all done. Big, long, ugly formula. Oh, this is a cosine. A cosine. There we go. Looks good. Alright, and now we need b. Okay, that's just 180, and we gotta convert these into degrees, because all of the cosine and sine in Python is done in radians. And 2 degrees. And this is C. Alright. Now we just need to translate the cam sprocket, or rotate. We don't have to translate this one because it's already centered at the origin. And that's if when I did the other one, it would have just been nicer if I would have just made another sketch, put it on the origin, and then we wouldn't have had to play around with the math.cos. But you get a better visual, and it's more like an assembly. But if the two things aren't connected, like they're not linked somehow by a physical link, nope, that's not right. I must have missed something somewhere. Let's see here. We're actually solving for. Alright, I need that in degrees. And then B will be A minus C. And we need an offset of 30 degrees because the angle starts at 0. But in reality, our assembly didn't start at 0. And then we'll put these ugly conditional statements in, just because if we're just between just this one thing, we only need to spin or rotate if our angle is between here. There's probably a better way to do this, but this is just quick and ugly conditional statements. There's that one, and then I have to do the next one if it's a negative quadrant. So if we're in here, we're in a negative quadrant. And we'll rotate one way if we're positive quadrant. And if we're negative quadrant, we have to go the opposite direction. Alright. And that's actually like 30 to 90, and these should be ands, not ors, and I think this will work. Let's see what we get. Nope, not quite right. Still something a little off here. What do we have? Yeah, this is supposed to be A, not B. We actually don't even use this B. Yeah. And the offset of 60 goes there. Let's see what we have. Hey, that looks better. Oh, still something a little off. It's got a little plinko action to it. This, yeah, has to get converted to radians, and we'll subtract that 60 out of there too. And there we go. That looks a lot better. All done. That's all there is to it. A little bit of trig and some OpenGL commands. And if you ask me, that's a lot easier than trying to put it in Inventor and do all that stuff. So it's all done. Our mission is accomplished, and we have a Geneva cam sprocket that's animated. I hope you enjoyed the tutorial. Here, I went back through Blender, and I smoothed out these radiuses and stuff. This doesn't come through as good as it does on my computer, but just because of my image capturing software and stuff. But this actually looks really good, and if I spend a little more time on the lighting, it looks as professional as Inventor, and costs a whole heck of a lot less, and it's easier if you ask me. Hope you enjoyed the tutorials. See you later. Bye.